Now, if we because we have been asked to find the V. Now, V must be equals to the radical of 4 divided by 3 GH. Kwa ndo formula yetu atakuwa ni huyu. Therefore, we are supposed to conclude by saying that equation number 2 is the velocity of the center of mass of a solid. Kwa huyu equation number 2 huyu atakuwa ni equation number 2 atakuwa ni velocity of the center of mass of the solid cylinder. Huyu ndo atakuwa ni velocity wa center of the mass here as we have tried to see. Kwa atakuwa ni velocity wa at the center hapa. To velocity atakaye exact kwenye ile solid body at the center. So after this one, my dear student, let us look another example. And our example number 15 for our first topic. And then this one give overview about what we tried to see on the past lectures. We say that here our example are explaining about the rolling of the rigged boards. Now assume a body rolling down an inclined plane. We have the body, and that body try to roll downward on an inclined plane, having the radius r and also the radius of gyration at this one. That body contain two radius, the radius r and also the radius of gyration that we tried to see on the past lectures. The radius of gyration, it is not a new term. We say that when we talk about the radius of gyration, this is the distance from the axis of rotation to the point where the mass is assumed to be concentrated, and also at the moment of inertia remaining unchangeable. So the body starts moving from the height h and reaches at the bottom with the velocity at this one. Kwa yule body the body should start moving. The body should start moving. Kwamba yule body ataanza kurotate, ataanza kuroll katika height ya h, at the height h and reaches the bottom with the velocity v. Atafika kwenye bottom with the velocity v, as we try to see, my dear students here. So what we are supposed to do here, the things that we are supposed to do, first of all, we are supposed to understand the terms that are found into our equation here. But on our equation, we have the body rolling. When the body is rolling on the inclined plane, the key term that you are supposed to keep on your mind is it must have the angle theta. It must contain the total kinetic energy, which is given in terms of the rotational kinetic energy and also the translational kinetic energy. Also, it must contain the potential energy and the kinetic energy and the mechanical energy is assumed to be conserved. That is what we are supposed to keep on our mind. We are supposed to know when the body is trying to rotate on an inclined plane. So consider free body diagram for a body rolling. Now we are supposed to see the solution of this question here. And our solution say that we need to consider the free body diagram of for a body rolling down. Now let us go and see the free body diagram that show the body which is trying to roll on an inclined plane and having the radius r and the radius of gyration which is equal to k. Starting from the height h and reaches the bottom with the velocity v. So it start from the height h na ikariach at the bottom with the velocity v, as it is shown on our figure here. So once we observe our figure, on our figure, this figure number 24 for our first topic here, explaining about when the body are rolling down an inclined plane. The body trying to roll on an inclined plane, as what we observe on our figure. So as we see, this is our inclined plane, and this inclined plane having the height h, as we see it having the height h, and also having the point A, which is indicated at the top, and also we have the point B, which is located at the bottom, as we try to observe here. Now our body here is rolling downward, but we know that it contain the inclined plane contain the angle theta. As we see, we have the angle theta. Now they are moving the body rolling toward the following the condition of the angular velocity. Kwa hiyo ilikuwa inaroli kwa kufuata the condition the angular velocity. Kadri inapo long pale, ile angular velocity ina remain the constant, inakuwa either inaongezeka au ina remain constant. So what we are supposed to do from this figure is that because we have this theta, now we are supposed to consider this body that is rolling here and try to dissolve so as to obtain the formula of the vertical axis and also the formula of the horizontal axis. If we observe, we should see that the angle theta will appear at this point. As we see, we have the angle theta, and also this line here could represent the mg, the resultant. Yule atakuwa ni resultant. Kwa tukiweka dotted line hapo ili tuweze kupata yule horizontal forces kama tunavyomuona, ili tuweze kupata horizontal forces hapa. Tutakuja kupata sasa, ukisha dissolve utapata the horizontal axis must be equals to mg h to mg sin theta, while the vertical axis, it means the vertical axis could be represented equals to mg cosine theta. This is obtained from Sotoka here by assuming that mg become as the resultant or become as the hypotenuse, my dear students. So after observing this figure here, now let us go what we have been asked to do on our question here. So since the total energy E at the top of the inclined plane is the pure potential energy, and the kinetic energy this one. So as we know that we have to record that since we know that at the top the mechanical energy, at the top the total energy is equals to the kinetic is equals to the potential energy, while at that top at the point A the kinetic energy is equal to 0. Kwa sasa tukitembea na hiyo idea kwamba at the top potential energy anapatikana lakini kinetic energy ni sifuri, na at the bottom yule kinetic energy anapatikana lakini potential energy anakuwa ni sawasawa na sifuri. Tukitembea na hiyo concept, basi tutamwambia kuwa kwa kutumia moment of inertia I, kwa kutumia moment of inertia huyu I atakuwa ni sawasawa na mk square, where I represent the moment of inertia of the body that is rolling on an inclined plane, while this m represent the mass of the body, and the k represent the radius of gyration. That is what we try to demonstrate. While this angular velocity, as we see, angular velocity must be equals to the linear velocity we divided by the radius. Kwa sasa kinachotokea nini? Tutarecord the conservation of the mechanical energy, ambaye anasemaje? Conservation ya mechanical energy anasema kwamba yule total mechanical energy aliyepo at the top lazima atafanana na mechanical energy aliyepo at the bottom. That is the idea that we are supposed to consider. As we see that mgh must be equals mgh must be equals to a half mk square. Instead of writing the moment of inertia, tumeweka ni sawa na mk square. Mk square times the angular velocity square. Lakini angular velocity square tulimsema hapa, angular velocity square ni sawa na v divided by r, while I is equal to mk square. Kwa tukisubstitute pale afu tukatoa ile mass, kwa sababu mass atapatikana ni common, tutakuja tutapata sasa kumbe yule velocity, kwa sababu ni common, tutamfact out. Kushamfact out yule velocity wetu atakuwa ni sawa na radical of 2gh, then we divide by 1 plus k square divided by r square, where k represent the radius of gyration, while r represent the radius of the solid or the radius of the rigid body, while this g is the acceleration due to gravity, lakini h ana represent the height of the inclined plane from the bottom up to the top, where v here ata represent the velocity of the rigid body. Kwa tuta conclude kwa mwambia kumbe if we have the radius of gyration, or the velocity in terms of the radius of gyration must be equals to the radical of 2gh divided by 1, then we add by k square divided by r square. So by saying that, my dear student, this is the end of our session here. Now I would like to welcome you again for another session. I wish you all the best. Have a nice moment.